So welcome again, boys and girls, on lesson 4. We are on board this ship that is taking us to KCSE. You better board it, otherwise you will not get there. Right, so today I want us to look at this so that I explain what I meant in lesson 3. This is a circuit which will have instruction on how to go about it. So what was my point number 1? Arrange items the way they are. Okay? You have to arrange the way they are. So if I am like this is my paper. Okay? So I'm going to arrange farthest from me. Farthest from me, there will be 2 switches. Farthest from me, there are 2 switches. One here, the other one there. And then somehow in between the middle line, I have galvanometer, I have capacitor, and I have the resistor. This is a fixed resistor. Okay? And then extreme right, I will have source of PD. My PD source, which is a battery of 2 cells, will be on my extreme right. Okay? So let me show you. We focus there. Farthest from me, I have the 2 there. Okay? But I'm missing the key. Let me get the key. A switch has its key. Okay? That is what completes the circuit. So I have the 2 switches, my farthest. You can look at my paper, I have put it here. That is your paper in exam. That is your paper. The 2 are far. Then somehow in the middle, I have the zero-centered galvanometer. I have the capacitor, whose capacitance is written like this is 4700. 4700. I don't know if you'll be able to see. 4700. It is there just below the galvanometer. Below the capacitor, there is a fixed resistor R. Okay? Will you be able to read? Yes. That is fixed resistor R. I put it below the capacitor. On my extreme right, I have the 2 cells. The 2 cells are in series. We talked about that. So this is what I meant by 1. Okay? You have that. Then I don't have the voltmeter in my system. But I want you to learn how to identify loops. Like now, this is a loop, this connection, and this is another loop. So there are 2 loops. Okay, we go back. That is 1 loop, mzunguko. There is another loop, mzunguko. Okay, so I want to connect this with the open mind. But let me also bring to your attention on the number of wires. I need wire number 1, for example, which takes me from the source, from the switch to a junction here. Let me call it that. You can have simplified, but I want you to get it right. There is another wire number 2 here. So the wire number 1 and 2 are going to meet at that dot. Wire number 1 and 2 are meeting there. Okay? Then I have wire number 3 from here all the way up to here. So this is wire number 3. Okay? I'm showing you wires. I've not started connecting. Then from here you can go all the way up to there. wire number 4. Then from here up to here, wire number 6. Okay? Then we come here. You can have 7, you can have 8, you can have 9 and 10. That is the maximum. That is the maximum because you are beginning. That is the maximum. But you may not need all of them. I'm only giving you a picture of those lines we draw represent wires. So I've taken you from one device to another because what is the function of these wires, connecting wires? They are connecting wires. As the name suggests, it connects one device to the other. Okay? Now, you may simplify this because it is very rarely you are asked to have 10 connecting wires. Very. How do you simplify? For example, this wire and this wire, they can meet at a terminal of R. So I don't need number 10. I don't need number 10. They are both going there. They're both going there. I don't need number 10. Already now I have 8. Then you can work with the rest. I think it's not a big deal. I can work with them for beginning. So let us go to business now. I go back and remember we have identified 2 loops. So I can try from here, I come down, I finish 1 loop. Okay? So let us do step by step. From the source, this wire number 6, I place it. Okay? I place it. I connect wire number 6. I've already done that. Wire number 6 connected to source S1. I've done that. I will show you. Okay? Wire number 6 connected to, I want us to follow. So I've connected from here to here. Now I need wire number 1 and wire number 2 and wire number 3. Remember, number 7 is not necessary because 1 and 2 can come to G. But I want to take you step by step and focus there now. Okay? So I've connected from the source up to S1. I need a wire from S1 to meet another wire from S2, and they should go to the galvo. So look, galvo is there. I connect from S1. From S1, I can connect to this wire. So in a sense, I'm talking of S1, I've connected it to galvanometer. I'm doing 1 loop from the source to the switch. From the switch to galvo. From galvo, I connect it to capacitor. So from galvo to capacitor. This is my galvo and this is my capacitor. Okay? So you will start getting some displacement there. And then I have from capacitor to the resistor. And then from resistor, I go back to the source. From resistor, I go back to the source. From resistor, I go back to the source. I'm done with 1 loop. I'll repeat. Okay? I'll repeat. After arranging, I started with this wire. I connected to the source. So what must you take care? I start from the particular point until I go back. That is the sense of the loop. That is the sense of a track. Okay? If you run from one point, you go around the field, you come back. That's a loop. I started from the source. I went to the switch. From the switch, one, I connected one up to the galvo. So I took one from the switch and another one from the galvo, then I clipped it, awaiting another one from there to go round again. But let us go step by step. So another wire, it is you come and then leave. So it came through this point, it leaves from this point. So from galvo to capacitor, then another pin of the capacitor to resistor, and then from resistor, there are two terminals. So the second terminal is connected back to that. That is a loop. That is a loop. See, I started, maybe I show you again. I started from there and I've come back. That's a loop. Now, what am I going to do? I'm going to go on now with this loop. I start from here and I will come there. See, already this path is connected. So I'll start from galvo to the switch 2. Then switch 2 comes to R. Very simple now. Okay? There. So I want you to get this. This is very interesting now. You see, why did I use this? So that this can also come here. This can also come here. To give you the idea, So you can see there is wire 1, wire 2, and wire 7. That. Okay? So I've connected galvo to switch S2. And now I require S2 to come to R. Look at this. This was the last wire I connected. Okay? From R to the source of PD. So I just come and clip this one also here. Can clip it there. See now? There. This is my R. You can see my R. So there is this wire going back, and I have just connected from S2 to this terminal of R. Now, my connections are complete. I read now the question. For example, let me get a question here. What was the question? What were we required to do? What were we required to do? We were required to close key S1 while S2 is open. So I'm going to close S1, but S2 is open. I want to close S1 while S2 is open and describe the behavior of the pointer of the galvo. I'm going to see what happens. Okay? I hope you will be able to see here. So I'm going to connect there. See, it has deflected. I will repeat. S2 is not connected. There is its key. We are only using S1. There. Can you see? it has deflected. Let me just shift the camera a bit. See what is happening now? I want you to observe, see what is happening. Just concentrate and see what is happening. Okay. Good. Let us take back our camera. I'm sure you can see. Okay. Now, the zero-centered galvanometer is a device that will show you flow, will reflect what is happening in the wires. It is kind of informing us. It is like we don't see wind. We don't see wind, folks. We don't see wind. We can see the effects of wind. If wind is blowing, you have a picture of our school, many trees. If wind is blowing from east to west, the branches lean towards west. What about if the wind stops? Get it right? Wind blowing from east to west. We are seeing the effect of wind. The wind remains this for as long as there is wind. But when the wind stops, okay. Now, what are we going to write? What are we going to write? Let me just give you a simple thing. What are we going to write? Okay? We have seen what has happened. Now, what are we going to write? The pointer deflected. That is what you observe. The pointer deflected away from zero. So whether you tell us on the left-hand side, right-hand side, no. The issue, even if you add that, it does not add mark. The issue was, your observation is deflected away from zero. Okay? Then, what happened? Gradually came back to zero. We shall do it once more. To refocus. The key is here. The S2 key is here. S2 key is here. Okay? And the galvo is here. So, we put there the key. I've disconnected somewhere. The cells. Let me check where have I touched. Okay, let me check where I've touched because I'm not getting. So there must be somewhere it is loose. Those are troubleshooting areas. Again, I'm not getting the deflection. Let me see the source. I'm trying to see the source, the cells. If I touched and they slipped the right position, You'll be able to know. It's not. There you are. Okay, I'm trying to counter check what could have happened because there's no deflection now. Seems there. No deflection still. So I have to get, let me get another pair of cells and wires so that we can see again. Okay. Let me see if I can have another source. I want to see what went wrong. Let me see if I can. I want to change if I want just to use the same cells, but I change the. I want to change and use the same cells so that I don't just get this back here and that back to another. Yes, let us see now. Right, so maybe capacitor. I use another capacitor. I get another capacitor. You have to get another capacitor so that we see what could be happened. The same capacitor, you can get the same 47. 47. Let me get. So let us. These are the same capacitor. The capacitance is the same. So I want to see what could have happened here. We see we get so that we get the correct. Let us see again. Is there anything? Yes. That's nice. Okay? That's nice. So we are going to do it again. I've removed the capacitor that was there. Maybe something happened. Okay? So we are going to do it again. I'm going to put the switch 1. I'll do that. This is for this. This is for that. So I want you to observe here. Okay? That is the pointer. You can see it. Now I'm going to put in there. Look at that. Look at that. Again. Should be able to see now what is happening. Okay. You can see the whole setup. Sure, you have better eyes than mine. Mine are aided. Okay. Let us take back and fix our camera where it was. There. Wait for it. Okay. it will go back to 0. So that observation should have been made by all of us. The pointer deflected, even if you said in bracket to the left. The key observation was deflection. Another key observation is after it deflected away from 0, it then gradually came back to 0. And therefore, what is the inference? What does deflection tell us? Okay? Deflection is a sign that current flows. Okay? So, initially, there was high current. You know, when we are charging a capacitor, remember, the positive potential of the source draws electrons to it from plate that is next to it. The electrons come. Okay? So initially there is high current and then gradually reduces as capacitor acquires the charges. So once the charges are there, when the wind stops blowing, it is back to 0. Okay? So it gradually goes back. Now, I want us to just finish by looking at open switch 1 and then close key S2 and describe the behavior. You know, we have charged this capacitor. Anytime the capacitor is connected across the potential, it is to charge it. So in other words, if you remember plate A and B, if plate A has 7 positive charges, then B has 7 negative charges. So it is charged. Now we are going to close S2 and open S1. So I will not wait it because you know I'm dealing with time and cameras. So I'm going to open this. This is S2. I hope you remember. This is S1, S2. So I'm going, we are told, open S1 and then close S2. So open S1 there, then close S2. Look at that. If you are keen, you saw what happened, eh? Okay? Look at that. Okay? So what are we going to say? The pointer deflected in opposite direction away from 0. Then gradually deflection came back to 0. Okay? Folks, these things require practice. Okay? They require practice. If you practice, you get them. If you don't practice, consequently, you don't get them. So quickly, I have S1, check, deflection, remove, then put S2. It goes the opposite side. Okay? What you are to write is describe the behavior. And then from that behavior, we state what does it mean, the inference, what does it mean? Okay? So reducing current must be there. This is about current. Reducing current as capacitor discharges through the resistor. Okay? Ladies and gentlemen, you can have this circuit and practice what it is, what it means. Where do we use each device? I want us to keep on pushing until the exam time. When you go back to school, please get some time for yourself so that you grasp what are the skills, what is it that I do. Once you understand, once you get equipped with the right skills, you do the experiment faster. Then you leave the rest for graph work and some computation on the table. Next time, we shall connect a simple circuit again to show you. After that, you can now continue on your own. We still have to do some mechanics, which has problem in writing the time for oscillation, even carrying out oscillation. Please keep on subscribing till lesson 5. Bye-bye.